To understand the concept of a sampling distribution, let's have a look at the example. So suppose in a certain part of Canada, the daily high temperature recorded for all past months of January has a mean value of 10 degrees Fahrenheit and a standard deviation of 5 degrees Fahrenheit. So as you can see, the mean value is the so-called population mean value, and standard deviation is a population standard deviation. And we know because the mean is denoted by mu, and standard deviation is denoted by delta. And let's assume that an experiment is conducted, and this experiment involves selecting 25 daily high temperatures from the records of past months of January and calculating the sample mean. So out of this record of all past months, randomly 25 months are selected, and the average high temperature is calculated. And let's also assume that this experiment is repeated many times. So during the first experiment, we get that the mean value of the sample is 9.8 degrees Celsius. During the second experiment, we get the mean value that is 11.4 degrees Fahrenheit. And during the third experiment, we get that the mean value is 10.5 degrees Fahrenheit, and so on and so forth. So this experiment is conducted, 100 times, 200 times. After we've got all those sample mean values, we make a histogram of all of them, and by making this histogram, we get what is approximately found to be the probability distribution of the mean values. And if x with the bar, so the mean value, the probability distribution of x is a good estimator of the population mean, we would expect the values of the sample means to cluster, so to be around the population mean, as we can see below. So the true population mean is 10, it's in the middle, and x with the bar, so the mean values, the sample mean values will be around this value of 10. And this type of probability distribution that we get here on this graph is a sampling distribution, because it is generated by repeating a sampling experiment many times.